2022 Paper 1. Question 1. Which statement about all physical quantities is correct? So all, which means they want scalar and vectors. And both have a magnitude, a unit, and a direction. Okay, question 2. Which graph represents the motion of an object that is dropped from rest and falls 45 meters? So as we can see, this is a velocity time graph. The area under a velocity time graph, the VT graph, will give us displacement. Okay, and in this case, the displacement was given to be 45 meters. So we're actually trying to find the graph that will give us 45 meters, the area under the graph. So for this, half base times height, since it's a triangle, base times 3 times height 30, we find that it gives us 45 meters. Question 3. A child sits on a rubber ball and bounces up and down on the ground. What stays the same when the ball hits the ground? The mass, always constant, unless it breaks into pieces. Question 4, not tested. Question 5. A rocket of mass 16,000 kg, m, when it's on the moon, it experiences the moon's gravitational field strength of 1.6 Newton per kg, small g. What is the weight, W, question mark, of the rocket on the moon? So formula, W equals to mg. Mass is 16,000 times moon gravitational field strength, 1.6. You get 25600 newtons. Question 6 not tested. Question 7 not tested. Question 8. How is pressure calculated? P, question mark. Formula for pressure, P equals to F over A, force over contact area. Question 9. A man with his ankles tied to an elastic rope steps off a bridge. During the fall, his gravitational potential energy is converted at various stages to kinetic energy, elastic potential energy in the elastic rope, and thermal energy due to air resistance. At his lowest position, the man is at rest. So at rest means velocity equals 0. And he has lost 30,000 gravitational potential energy, and thermal energy of 1,000 joules has been produced. Okay, so this is GPE here. Which rows shows the values of the kinetic energy and elastic potential energy at the lowest position the man reaches? So let me write the conversion. Gravitational potential energy at the start is converted to kinetic energy as he falls through the air, and after that stored as elastic potential energy plus thermal energy. So in the question, we know that 30,000 joules of energy initially will be converted to 1,000 joules of thermal energy, which means elastic potential energy is 29,000 joules. Because conservation of energy states that energy can be created or destroyed and only converted from one form to another. So kinetic energy, because at rest V equals to 0, K is 0, elastic potential energy is 29,000, thermal energy is 1,000 joules. Question 10. What is a form of energy? Light is a form of energy. Okay, friction is not. Friction is a force. Okay, question 11. During a change of state, the molecules continue to move at random throughout a substance, and the force between the molecule increase. So if it's still moving randomly throughout the substance, it's actually from gas to liquid, because in solid they vibrate about their fixed position. And this force that they're talking about is the intermolecular forces of attraction, okay, that increases from liquid to gas. Question 12. A thermometer is placed in a beaker of a liquid substance its temperature is recorded as 10 degrees C. So the substance is cooled to minus 10 degrees C, and the readings on the thermometers are recorded at regular intervals. A graph of temperature against time is shown. Which part of the graph represents when the thermometer is losing thermal energy to the surrounding substance, which is actually the liquid. So at R is actually the liquid. As it starts to cool, it undergoes a state change, liquid plus solid, which is freezing. And finally, at T, it should be a full solid. At S is when there's a change of state. And we know that the change in temperature will be 0. So if there's no change in temperature, the thermometer will not give out any thermal energy as well. So the parts that the thermometer is losing thermal energy to the surrounding substance must be only R and T. Question 13. Waves are made in a vapor tank. What is transferred by waves? So we know that wave transfers energy without transfer of metal. Okay, question 14. Which component of the electromagnetic spectrum has longer wavelengths than ultraviolet and higher frequencies than microwave? So let's recap. It starts with radio wave, microwave, infrared light, visible light, UV, X-ray, and then gamma rays. From left to right is increasing frequency. From right to left, it's increasing wavelength. Okay, so now they're looking for longer wavelengths than ultraviolet, which means in this region. Okay, and higher frequencies than microwave, so in this region. So the only two that overlaps are infrared and visible light, but the only option here is infrared. Okay, question 15. The diagram shows how the displacement of a particle in a sound wave changes over time. How do the volume, which is also known as the loudness, and loudness is proportional to amplitude, pitch is proportional to frequency, change over time as it shows. Okay, so we can actually look for the amplitude of the wave. Okay, we see that the amplitude of the wave, you can take the 2A. So amplitude decreases over time, so it means the volume should decrease. For the pitch, we can take one full wave cycle like this. You realize that the frequency actually increases because now the period is actually shorter. This is period. You see that the period is shorter, and formula, period equals to 1 over frequency. Frequency equals to 1 over period. If the period becomes shorter, the frequency increases, so the pitch increases. Okay, question 16. The unit for charge is the coulomb. What is equivalent to 1 coulomb? The formula, Q equals to IT. Q is coulomb C, I is ampere, SI unit for time is seconds. So ampere, 1 ampere times 1 second. Question 17. The effective resistance of 3 identical resistors connected in series is 6 ohms. Connected in series 1, 2, 3. The R total is 6.0 ohms, which means each of them is 2.0 ohms. So what is the effective resistance when two of these resistors are connected in parallel? So in parallel, 2.0, 2.0. In parallel, formula RT 1 over RT equals to 1 over 2.0 plus 1 over 2.0. You calculate RT equals to 1.0 ohms. Okay, question 18. The diagram shows a circuit containing 3 lamps connected in parallel. The switch is closed. How does the potential difference across each of the working lamps M and N affected when one of the lamp breaks as shown? As we know, this is a parallel circuit. So the EMF, voltage 1, voltage 2 are equal. EMF equals to V1 equals to V2. So the PD is unchanged. Next, question 19. A mobile phone has no charge in its battery. The mobile phone is charged by connecting it to a 5.0 volt supply with a charging current I for 2 hours T. But you must make sure that you convert the T to seconds. Okay, so T is equals to 2.0 times 60 minutes in an hour, 60 seconds in a minute. What is the total energy stored E question mark in the battery after this time? So there's two formulas that you need to use. First formula, P equals to VI. And second, P equals to work done over time or energy over time. So two formulas. We can rewrite E equals to PT from second equation. E equals to VI times T, which equals to V 5.0 times I 0.50 times T, which is 2 hours times 60 minutes times 60 seconds, which will give you 18000 joules. Next, question 20. A hairdryer contains a motor and a heater. The plug of a hairdryer contains a fuse. Which statement about the fuse is correct? So, remember, fuse and switches are connected to the live wire. Okay, it does not join the live wire and the neutral wire. It's the hairdryer that joins the live and neutral wire, or the electric appliance. It protects both the heater and the motor. That's correct. Okay, both. It protects both. So D is wrong. And that's the end of paper 1.